Alright guys, so I'm going to go over using Vcarve Pro to actually design the Titans of CNC Academy Titan 84L, which is a lathe project. Um, the very first thing we have to do is we have to set up our work area. So we go over to Job Setup, and if you guys don't know, that's this button right here, Set Job Dimensions and Origins. We click it, single-sided. We need a width and a height of our work area. Um, the thickness doesn't really matter. We're going to be in millimeters because the Rownd CNC lathe uses millimeters. Um, you can set it material surface or bed because we're not generating any Gcode out of Vcarve. Our XY datum position, you either need to be in the center or you need to be in the upper right hand. Do not use any offsets. And scaling design, you don't have to worry about. Model resolution, you don't have to worry about either. So you just click OK. And now our work area is set. Okay. On the screen, you will see a couple things. One, I took the PDF and I made it a picture so that I actually have a blueprint to go by on my part. Then on top of that, I have here a couple of my tools. I have my 60-degree threading tool. I have my BMC or MBC SDJCL, which is a 10 by 10 millimeter HO7 55 degree uh, roughing light finishing tool. And then I have my groover, which is a 2 millimeter groover. We're going to modify this a little bit from the blueprint, but I wanted to show you how to actually create the DXF file that we will then import into GRBLGru lathe. All right. So as you can see, we have the blueprint here, we have the tool assemblies here, and then we have our finished drawing here, which I've already done. So we'll go through and I'll actually walk you through designing this based on the geometry and dimensions given on the Titan's blueprint. Okay guys, so we're going to start drawing, and for the Rownd CNC lathe, we need our origin to be right here, and we're actually going to operate in the negative quadrant, which would be the lower left quadrant. And we're going to start going ahead and moving things. You'll see stuff moving on the screen. To get that to move around, I hit the center mouse roll button and I can drag it up and down. If I roll the button, I can zoom in and zoom out. Right? So for me, I'm going to select the blueprint and I'm going to move it over to here just so I can see better. This gives me pretty much everything that I need. Remember when we're doing this, this gives you a full diameter setup. I do not need the full diameter, I just need a half. And then GRBLGru will revolve it along the center line. We're going to start with the 0 line, and we know the overall dimension of this is 1.8 inches or 45.72 millimeters long. So the very first thing I'll do, I'll move this over. Let's see, let's move it over to here. Okay, so I'm going to take a line and I'm going to draw a set of crosshairs right there, and then I'm going to do another one right here, and I can trim this if I want to trim it like that. So basically I just go to the interactive trim tool and I trim. All right, so now I know that I need a 1.8 inch or 45.72 millimeter line from this line back here. So we can actually just go do an offset of 45.72. And let's see here. Oh, we gotta select the vector. Okay. So this is our overall length. And once again, we're going to be building this off of a half. We only need to build this lower half, but this gives us uh, our full diameters. Okay, so we've got our first line, and now we can base everything off of this. And the reason why we do that is this right here gives us our 0 point, so we can do our offsets on a lot of this stuff. Okay, so if we do a line here, or we can do an offset. So I use the offset a lot just because it gives me a lot of my lines really quick, really easy, and then it can give me my intersections so that I can use point editing. So for me, what I'll do is I'll take this and we're going to do it inwards because now we want to be inward of this line or to the right. Okay, and we need one at 34.925. So now we do one at 34.925. Offset. Keep forgetting to select my vector. Okay, and this is my 1.375 line, which would be right here. And that's actually the start of this arc. Okay. Now I need one at 1.5 inches or 38.1. So we'll do one at 38.1 and offset that. Now we have our 1.5 inch line. That basically sets everything up for this bolt shape. This is actually the beginning of a rocket tip. And now we can start laying out lines for the threaded areas. So we have a 39.751. Okay. There's that. And now we have our 1.80, which is this line. So we've done all of our horizontal lines or horizontal measurements. Now we can start mapping out some of the other stuff here. All right. So now, what do we want to do here? We can take this and set our actual dimensions for this part and shrink this down. And then we can work on this little nub here. So I think that's what we'll do. All right. So I've got a point, what is that? 0.8 or 8.89 millimeter or a 0.35 diameter. So I will need to divide that by 2 to get what I want. So we'll go here and we'll do an 8.89 divided by 2, 4.445. Okay, so we can leave that right over there. And now we can actually take this and do the 4.445. And we're going to do both sides. We're going to select this one and we're going to offset it. And we're going to close this. Now we're going to do some trimming here. You don't have to do this. You can go through the shorter path of this, but I like doing it this way just because I start seeing it really take shape. There's multiple ways to do this. You don't have to do it my way. I just like doing it this way. It makes sense in my mind. Okay, so now we have this line right here, which is this dimension right here. Okay, and you'll notice we're working with a lot of the prime geometry, and then we'll go from there and make everything else. So our overall diameter, the overall outside here, if we look up, there's our major diameter is 0.950 inches. That actually works out to 24.13. So if we take our calculator, we'll go 24.13 divided by 2 equals 12.065. So now I can take this and I can offset by 12.065. Offset both of those. Now there's my major diameters. So by doing this, I can come through, I can trim that one, I can trim that one, that one, that one. I can also trim this down to the 1.5 inch or 38.1 line. Down there, down to that. Okay, so that basically sets this section here, which will be this section here. All right, and then we have our diameter here. It's right here. So that gives us our starting part for right here. So I can actually do a node point here and here and set my radius. The way I get that nice swooping part. Okay. So now I can work on the threaded portions and then I can go from there. Need to do a little bit of cleanup here to get this threaded portion. and we're going to keep it as a major diameter right now. And you can see right here, there's a major diameter, a minor diameter, and then a pitch that details our threads, and that's found right over here. So we can look at our major diameter. It is 0.3737. Our median is 0.3690. So we're going to keep it as a major diameter at this point, and then we'll play around with it after that. So we've got a 9.49198. So we'll do a 9.49198 divided by 2. Okay, and that's going to give us 4.74599. Right? So now let's go here. Let's select this. Let's do an offset of 4.74599, and we're going to do both sides. Okay, and now we'll just do some cleanup on these lines. So we're going to click that, we're going to click that back, and we're actually going to clip this back because this is a major diameter for our threaded portion, which is right here. Okay, so this is our major threaded. This is our major diameter or minor diameter. Okay, now we need to get some information off of this. Okay, so this is a 0.065 length at a 0.238 diameter, and that equates out to that. Okay, so we need to take this 0.60452 millimeters and divide that by 2. So we go 6.0452 divided by 2 equals. And what you guys don't see is I actually have a pen and paper here. Writing down my calculation answers as I do this. So now I'll take this line, I'll do an offset, and I'll make that 3.0226. And I'll offset it both sides. There's our little relief for the threading portion. So now I can go in, I can clip this, clip this, clip this. All right. Now I have my major diameter here for threading. I have my relief diameter here. I have my major diameter here, and then I have my minor diameter here. Okay, so we're doing good on a lot of this. Okay. All right, everything looks good there for all the major parts. Now I need to do this part, and then that will actually design everything that I need. So we can come here, we can go there, and we can go there, and now we can set the radius at 3.298 or 83.7692. Right. So we can go 83.7692. And you can see there's our arc. So now we can trim the excess of this line. And we have our arc. So now the basic shapes are there. At this point, if I wanted to, I'm done with all the upper portion. So I can clip a lot of this stuff out. I'll just delete this. And I'll clip this. Notice I'm keeping my center line right now. And from there, we can add in our chamfers and our fillets as called out and all of this. Okay. So let's go ahead and add in our radius. Should we put that in there? So we've got a radius of 0.2 on this side and this side. That's why it calls out the 2 times. Then we have our chamfer called out 2 times from here. Okay, so let's go ahead and do that. So we're going to do a little more cleanup here. So I'm going to clip that, and do I want to clip that? Let's take a look. That's not calling out anything else. There is a chamfer down here that I need to make sure of, but I don't need this line either. So I have the overall shape right here. Okay. So now, some of this is going to be a little bit different if you're using Fusion, if you're using SolidWorks and stuff like that, because GRBLGru operates a little bit differently. We can trim up our line there. Okay, so we've got that. All right, let's do our radius 0.02, so that's a 0.508 fillet. So let's go up here. Let's do our fillet, and we're going to do that at 0.508. And we're going to pick right here. You see how it has the check mark? Now it does that fillet for me. Okay, so that fillet's done. Now we need to work on the chamfers. And there's another fillet right here, which is a 0.635, which will be right here. So let's get that fillet in. And that's a 0.635. And for you guys that are wondering, that haven't caught on yet, I basically took the Titans of CNC, Titan 84L, and I just took all the inch measurements and changed them to millimeter measurements. Just by you take the inch, multiply it by 25.4, and that gives you your millimeters. Okay. So that's a 0.35. Yep. Okay. So we can go right here, and you'll see that it's not allowing me. You don't see the check mark whenever I get into that corner. And the reason being, if I will right click on that, it gets me out of my fillet. So now I need to figure out, if I select this, if I left click on this line, it should go all the way, but it's not joined. So on my keyboard, I hit Shift and select my second line, I go over here to this join function, click join, and it says that there are two opens, and if I join them, it'll make it one open. So let's join those. Now if I click this, now it goes all the way over. If I do my fillet and 0.635 and I hover right in this corner, there we go. Right click, I'm out of my fillet. Now all my fillets are done. So the only thing left for me to do would be to actually um, do my chamfers. And if you want to, if you don't want to, you don't have to, but you know, that's completely up to you in the way that you do it. Now, some of the things that I do whenever I'm testing stuff, uh, if I'm doing a project for myself, I don't worry about it much. Um, but there are times where I do worry about it. Um, if I'm given a part by a customer, I may have to get custom tooling or something like that. So if I go up here to my layers, you'll see I have a tool layer and a finished layer. So I actually already drew this. Okay. And it's a little odd right now because I did some different stuff um, in reference to what tools I have. So I'm going to unmark my tools, and you'll see I have tools here. So I have my grooving tool, and the reason why some things are different is because of the tools that I was going to use. Um, if I take this and I move this tip up, you'll see my threads have to stop there because of the interaction between this face of the tool and the end of the actual machine part. So if I wanted to do this for myself, I might just extend this down so that this tool can get all the way down to here. Um, that would be one change based on tooling. And this is my roughing tool that I'll actually use to machine. Let's do a Control Z and go back. So I'm going to grab this tool right at that tip. And you can see how it's actually going to try and cut. So to get in there, it's not going to be able to get this tool inside of that little opening because this area right here is too close. So I might actually change that geometry a little bit just to get in there. Um, these are all things that are based on projects. Another thing I could do is I could take my grooving tool. I could actually see if my grooving tool will fit. So my grooving tool won't even fit in there. So now I have to figure out, do I get new tools or do I change the geometry of this? In my case, it's nothing spectacular. But, I'm not doing a finished project, but I'm doing it to kind of teach myself how to generate code for the round lathe. So I just want a project that I can do. So I'm going to actually stretch this out a little bit, maybe make this like a 3 millimeter opening right here and be able to get my 2 millimeter grooving tool in there and kind of cut that away. Um, I may take that fillet out because I don't have anything that will work that fillet, or I could stretch this out to 4 millimeters, and that gives me a 1 millimeter movement in this area, or a half a millimeter movement. So a lot of this is up to you and your project. All right. So let me go through. I'm going to make the changes that I'm making to this. I won't video it because it's not the Titan's blueprint. So I don't want to confuse a lot of things with that. Um, but just be aware that you can change stuff based on your project. You may have to get custom tooling, or you may have to grind custom tooling to fit into some of these areas. Now, a lot of Titan's machines have an automatic tool changer. Round does have an automatic tool changer. Titan uses uh, Kennametal's tooling. So there are tools you can order specifically for this project if you're doing the academy. So you're actually trying to teach yourself uh, lathe work and aerospace work for the round CNC lathe. Um, so be aware of some of these different additions and applications. Okay. So I'm going to take a look. I might do some chamfering, and I might do some expansion. I will have this PDF available, and the, um, I will have the modified DXF file for excuse me, I will have the modified DXF file for the uh, part that I make, and we'll go from there. Right? Okay, guys, as you can see, I did my little chamfer here, little chamfer here. I moved this out so my grooving tool could get in there. That way. So I use your grooving tool, go in here, grooving tool, go in here, grooving tool, go in here. Then I use this tool to actually machine. And all in all, that looks good. So let's see what we can do for DXF and uh, get into GRBLGru. Alright, let's start to not deleting but erasing some of the visible tools. So all this geometry. I'm not showing over. There's three inputs. It's now closed. Well, it's one line, it's not closed. First closed, we have the center line there. Okay. So let's move this to draw here. Okay. Let's choose that. Okay. So there's our actual part. And I have a few things that I'm going to do to it to make sure that we can machine it. We're going to use two tools, which means I have to zero out two tools. I'm going to have a minimum radius in GRBLGru that will allow a little bit of stick out here and here to be machined. Okay, all looks good. Let's export this DXF. Export DXF. As you can see, I have one of them saved. Put this as E for edit. And save it. And that's all you gotta do. Now we'll go over to GRBLGru. We'll start setting up GRBLGru and we'll generate some code for this lathe project. Okay, guys, for GRBLGru, we're using GRBLGru Lathe version 1.70. This is a very inexpensive but really good piece of software to get started with the round lathe. So what I did was I used one of the conventional configurations. I just went up and chose the Boxford because it is a rear tool mount. For this, you don't need a control port. Your controller needs to be put in simulation, uh, and it's actually really simple to use. So picking up with the DXF file that we had earlier, I'll go in, I'll go up to File. I'm going to import DXF. We're going to do our Titan 84L edited. That's what the E is for. And That brings it in. We go to 2D. Okay. So there is our toolpath as it lays. Whenever you first start an import in 2D, you're going to see this uh, job tree. And basically, right here is where you will add tools. So you'll just take a tool, select it, and go from there. Okay. Um, you'll also create tools here. So if I wanted to create a tool, I would take this one and I would copy, rename it, and go from there. Okay. So then you also have, let me get out of this, make sure I didn't change anything here. Okay. All right. You also have your chamfers, radius, threading, spherical. These are job templates to actually create like a chamfer line or a radius line or anything like that within GRBLGru. For me, most of my stuff is going to be done in either SolidCam or SolidWorks, I guess, SolidMaker, um, or Fusion, or the Vcarve GRBLGru setup. All right. So we don't use the post processor from Vcarve. We're using GRBLGru to actually generate our G code for the lathe program. All right. You can generate some of the applications through the 2D templates and go from there. Um, Up here, fixtures, you're going to have different driver fixtures. This would be something akin to like a lathe dog on a chuck. Um, Maybe for you wood turners, you have face drivers, which are basically just uh, needle style or screw style uh, pucks that the screw ends basically just dig into the back of the wood piece, and then it spins with the chuck. So you can add that type of stuff. If I do, let's just go to face driver. Let's see here. Oh, let's see. There we go. Man, there we go. Okay, there's our machine. Let's do a top view. Okay, so if we go to 2D and we select a fixture, and we can change these, and what you'll see is those fixtures will load right here where the chuck will be. Okay. All right. Now, job templates. These are what you're actually going to use to um, do your G codes. You have a rough and finish, auto start. It basically just defaults to this. Um, if you click here, it'll tell you down here what all of this stuff is and what all of these uh, fill-in parts are. Okay. Um, and then drawing, this is your DXF layer. And then your jobs tab is actually what's generating the G code down here. So right now we have auto start on the actual layer. So if we go here, you'll see actual layer. and then we have actual layer auto start. So that's this right here, and these are the criteria that we're going to fill in to actually generate a G code. Now, this is not an end all be all. This is a very inexpensive way of getting started in making G code. So understand that you're going to have to modify the G code a little bit afterwards. So we'll go through that. So we have our actual layer. The green check mark is here, so that's active. So basically right now, this is a roughing pass to get it to shape, and then a finish pass or passes. This is our lathe tool that we select. This is bar material, offsets, and then if we have a bar feeder, stuff like that. Okay, so operation mode, profile. So we want profile because we're not threading. Smart clearance. If we click here, this calculates the clearance plane adaptive to the remaining stock radius. Yes, we want smart clearance. If you pick no, um, that just gives you clearance around the ends of the DXF and whatnot. Um, our direction in which you want to turn, we're turning to the left because our chuck is on the left and our tool post is in the rear. Free entry, it uses an Fmax, so a feed rate max instead of a finished in feed to enter each line. So it'll basically wrap it into the material and then start cutting at the feed rate. We don't want that. We want to control how much it feeds in, how fast it feeds in. So we'll keep this on no. Um, Local order, this is X control. So we want to make sure we use this among everything. Uh, Radius minimum. So this creates a minimum radius along the center line into which the tool can go. If you set that at 0, it will cut exactly what the DXF has. If in my case I set this at 3 millimeter radius, so it will actually give me a 6 millimeter remaining piece, a quarter inch basically remaining piece to at the front and at the back of this that I can face and I can part off. All right. Um, that just gives me a little more stability as I start getting things cleared away and moving things around. So, all right, now we're getting into our roughing. So, is it active? Yes, we want it to rough. What is our offset? So, offset is how much material we leave for the finish pass. And the reason why this is important is if I have this set to 0, the roughing pass is going to go right up against at a high rate of speed. So we'll have a much rougher surface finish than what would normally be. Um, so I usually set this at anywhere from, I don't know, 1 to 4 times the finish feed rate. Okay. Our finish feeds, we're doing this in a simple wooden dowel. So our finish is going to be a 0.1 millimeter uh, finish. So this will give us 2 finishing passes. That looks good enough to me. In feed. This is the depth per pass, the depth of cut per pass. So for us in wood, we're going to do a 0.5 millimeter. I'm just going off the user manual recommendations for right now. Um, so we put zero point 0.5, enter. Okay. Our plunge feed rate is actually the feed rate the Z move or the X moves in. So our feed rates altogether are going to be like 250 to 350 millimeters a minute. Um, this is a light material. I'm going to go 300. We'll go 300, enter. And then our Z feed rate, which is what it's actually cutting at, we're going to put that at 300 also. Okay, GRBLGru does something a little different. It actually applies a rapid feed rate as a G1 movement. So it doesn't alternate between G0 and G1 for rapids. So you set the rapid feed rate here. The Rownd CNC rapid feed rate is 1000 millimeters a minute. I'm going to set mine at 800 just to stay under it. Uh, enter. Okay. Now, this is one thing that is a little odd. You have an indent left and right. So let's change this, and you see right here all of these uh wrap or roughing movements, and you see how it stops right at the ends of the design. So this line right here stops, this line right here stops. That means there's going to be excess material on the finish movement. What I normally do is I'll set that at like a 3 millimeter and a 3 millimeter. And now I actually overcut this, and it keeps the 3 millimeter minimum distance. Okay. So what that'll do for me is I overcut my finish by 1 millimeter. So that gives me a nice finish in here and here so that I can use my grooving tool to go in. Um, your border distance is from the left border. I keep that at 0. You can put that at 3 also if you like. Now look at it. Okay. So now you can actually see how it transitions things. I haven't really figured out what the border distance does. Um, so I keep mine at 0. I do a retraction of a 0.5 millimeter, and what that'll do is it will do a pass and then come out, do a pass and then come out. All right. So now at this point, all my roughing is done. Oh, I don't do a final roughing path. Um, I usually just do all my roughing, and I know I have multiple finish passes, so I go with that. Okay. All right. So now we're going to start the finish passes. All right. We want to make sure that that's active. Yes. In feed depth. So we want to, for our finishing passes, we're going to do a 0.1. Okay. Now our plunge feed rate and our regular feed rate are going to be in between 75 and 120 millimeters a minute. So let's say 100. Okay. We'll do this at 100 also. And we'll put the rapid feed rate up to the 800 because our max is 1000. Okay, now we have these indents. This is what I was telling you. I changed this to a lower value than what my um, my roughing indents are. So now you can see my finish pass is actually inside of my uh, roughing. Likewise, if you look right here, that's in reference to this number. So now it's inside of there. Okay. Um, Now, do we want a spring pass? I don't think we need a spring pass because um, I have a couple finishing passes. Now we need a tool selection, and for me, I'll be using a D-shape -30. So that basically gives me my SDJ CL tool, and it gives me my proper shape and everything. All right, and then bar material, if you're using uh, multiple pieces, you're using a long bar of it. What's your offset in between the parts, and what are the number of parts? And then if you're using a uh, bar feeder, I guess I haven't figured this one out either because I don't use it. Pretty much the only thing that I use is general roughing and finish and my tool shape. Everything else pretty much stays the same every time. So right now, the G code has been written and I can actually simulate it here. So I was in the 2D, I go to the 3D, and you'll notice my part and my tool are way away from the chuck. That doesn't matter. That is arbitrary, um, for the simple fact that it goes off of where you set your X and Z zeros. So we don't really care. Um, but if you want to kind of simulate where it'll be and everything like that, you use this button and now set workpiece 0. Okay, and that's how you can do that. Um, and it'll adjust it down. I can take it down here. I can actually set it inside of the chuck if I want. Um, None of this, even though it looks like it's going to hit the chuck in the simulation, it's not going to hit the chuck on the actual part because it's based off of your zeroing on the machine. So I usually just pick an arbitrary outside place. I set my stock diameter. So the wooden dowel that I'm using, uh, let's see here, I have it set at 32. Um, so we're at 32, 3220. Let's make that, let's set it a little big by half a millimeter. Okay. Now I'll just click up here somewhere and you'll notice I actually made my diameter bigger. Okay. So now we can replicate. We have our lathe shape and we can start. And it'll go through and you see every time it does a roughing pass, it pulls out a half a millimeter. Now it's actually doing the back end. Then it'll stop, it'll go up and it'll go up to the front end and clear that. And you'll see this orange line right in here, which designates the roughing passes. Okay. there we go. Roughing's done. Now it's going to do the finish pass, and it should do, I think, 2 finishing passes. And that's it. All right, guys, now we need to edit the G code. So we've created the G code by everything we put into the 2D here. We go up here. This will actually generate G code for us. Right? So let's pull that. Now we need to do a little bit of modification to the G code. We need to take our first steps in this and add a G18 work plane. And then we need to do a spindle speed or a chuck speed. We do S, and then we're going to do a 2500 RPM, and we're going to do an M3 to turn the chuck on. All right. Now we're going to do all of our rough passes. And I'm just looking. Okay. So there's where all of our rough passes um, kind of restart. Okay. So now we're going into our finishing. This is where our finish starts. You can see all turning, turning, turning back to start point. So we're going to add a G18 S. Let's do a 2800, and we're going to do an M3 just to make sure the chuck is on. We didn't have an M05 anywhere up here, so the chuck should already be on. This is just going to increase the speed. Okay. Now this should start all of our finishing passes. Okay. That's one finish pass. This is the second finish pass. And then it should go back to the start point. So we do a G18. Now we can do a footer here. And for our footer, we're just going to do this, takes everything back to an X0 at this yellow line and a Z0, which is right here at the end of our part. So we need to turn the chuck off and we need to stop the program. So for turning the chuck off, we're going to add an M5. Then we want to stop the program completely, no rewind. So we do an M30. You could do an M02 there. You could do a pause with an M0 and M00 and do a work pause. I just like the M30 because I know that that's done with that tool. So this would be one Gcode program. I'm actually going to have 2 separate ones because I'm going to go back and do another finish pass with my grooving tool to pick up this area here. It's going to come around, clean this up, and then it's actually going to cut into here. All right. And then from there, I'll be able to just cut it away and clean it up as I want, as I need. Okay. And it's really that simple to get Gcode from GRBLGru. Um, Once again, this is your inexpensive option. It's a very powerful tool. Don't get me wrong. It leaves a lot to be desired, but it is an inexpensive option to start generating code easily. It's kind of figure it out and just repeat all the time, and you'll be good to go. So we can file, save as, and now I can save this to uh, any of the options I want. In my case, I'm going to go to TL, and I'm going to call this Titan underscore 84LE, and call that good. Okay. So the big things to take away from this is how to import your DXF, how to actually set up your Gcode uh, text here, and then how to actually edit your text. So for GRBLGru, you have to edit the setup um, with a G90 G18 line and a S spindle speed and an M3 turn on. Once it's done with that, you shouldn't have to go back and do another G90 G18, but I do it just to be safe. So once it's done with its roughing, I do a G90 G18 S spindle speed or chuck speed for the finishing. Make sure the spindle is on. I cut, and then I modify the finish with a G90 G18 and an M5 and an M30. You realistically could put an S2800 M3 there, just like the rest of them, and that'll keep the chuck going, so that if it actually interferes with anything, uh, it will it'll be cutting, and it won't just ram your tool into the part while it's not spinning. You may lose the part, but you won't lose the tool tip, hopefully. Um, but looking at this, it goes to negative 12.062, and Z will be negative 48.390. Then it goes back to the starting point, so retracts to X0 and then to Z0 at the beginning of the part, turns off the chuck, stops the program. So you can see here it does a lot of feed rate. It generates a lot of useless code line in terms of feed rates and stuff like that, because it doesn't do a G0 versus a G1. It just does everything as a G1 movement. Right, wrong, or indifferent, it works, it's inexpensive, and it's a great way for you to get into generating some G code for your round lathe with very little issue. All right. All right, guys, so we're out at the Rownd CNC lathe, as you can see. One thing we already did was we homed, and I set my zeros, and the way that I set my zeros, if you look on the end, you can see a scratch mark. Let me open this up. Okay, this scratch mark right here, that outer rim, that's my scratch for 0 on Z. So I set my Z0, then I did a scratch mark on X at the wide part right here. I don't know, there, you can see it there.
I have a mandrel holder on this end, and that's just to get a rough area here, and we'll go from there. So the very first thing I'm going to do is I'm going to do a 40 millimeter long 3.5 millimeter cut, depth of cut, to get this round, and at roughly about 25 millimeters, so a little under 1 inch, and that will fit inside this chuck with no problem. Then we'll get our length based off of that with any added tolerances that we need. All right. Alright guys, so we've got the, let's see here, we've got the zeroing done there. 40 millimeters gets me inside the chuck and gives me a little bit of extra, so then I can measure everything out from that, and we can cut the excess off and we can go from there. So let's see what we've got in the next order. To remove this, I undo this handle and I back it out like that. I move it to the back, lock it. Now that's locked in. Okay. Now I can take my chuck key, undo my mandrel. Okay, and as you guys can see, my mandrel is just a 3D printed mandrel, just to get me a good 0 point to sit in there so that my chuck can grab a hold really good, and then we'll go from there. Alright, next part, you can see the marks already on there, but basically I wanted to make this round so that I also take some of the diameter down, and that allows this not to pull the jaws out whenever I clamp it. You can see I gave myself a little bit of excess. So before I do anything, I'll mark that, and I'll mark that. And what that will allow me to do is, now that's where my chuck stops. So I can go 5 millimeters above that, and I can set my Z safe and set all my zeros with a 5 millimeter clearance. Alright guys, so I have my chuck end, I have my 5 millimeter clearance, and then this is 50 millimeters from this end. So this is my warning zone right here. This is my stop line, so that I don't hit my chuck tooth, chip my tool, ruin my chuck, throw apart, everything like that. You'll also see I have a 3D printed dial indicator holder, and what this is for is squaring up my material, so you can see it goes back and forth, and I'll be able to kind of get a really good read on where I'm at with everything. I'll get it real close if I'm within like 5 thousandths or what is that, 0.01, I think, something like that. I'll do the calculations for getting it within 5 thousandths in millimeters. Once I register that, as within 5 thousandths, with any deviations in the surface finish of the material. Then I'll do a clean cut, then I'll re-optimize it and try and get a good zero. Okay? Alright guys, with some surface imperfections, kind of got a top dead center, and my tolerance. My tolerance is about double what I like it, but this is wood, so, you know, that's where we're at with it. So now I can undo that, do a cleaning cut, and see where we're at. Alright guys, I got my scratch test done, and I cleaned up the face. So that's my Z0, that's my scratch test. So basically I just fed in till I touched the face, then cleaned it, fed in till I touched the face, until I got this whole face smooth. Then I set my Z0 just by touching the 0 button. Then I moved up and over to a negative 2.5. So I moved 2.5 millimeters in to the material in Z. This is my Z axis, this is my X axis, okay? And then I just slowly brought it in till I did a scratch on the surface and hit my Z0 and then backed off. Okay, so as you can see, so now if I hit go to 0, okay, there's my Z0. Now if I hit go to 0, there's my X0. Should be right on, okay? So now we're ready to start the program and run it. So the way that we do that is we go here to load file. I have it right here. Double click, and now that's my file. I can preview it. This is all the information to start, and right here is the beginning of my program. Okay, so that should take me to X0, Z positive 3, X negative 1, or negative 0.001, X negative 0.5, and then Z at negative 4999. So that should be 50 millimeters from this face back. And if everything goes correctly, if I put my 50 millimeter scale there, I should just come up to this line. If it goes past that line, I'm gonna hit the E-stop and go from there. Okay, so all right, if we click run, we should start. So here we go. We're gonna click run. Okay. Nowhere near my chuck. So we shall return. start our finishing pass. So guys, this is our rough cut, and it did break off. That's a little too thin for wood, so I will repeat the process again, and I will strengthen out that top section and get a little more material in there for it to hold, and try and go from there. Okay guys, here's the new nub, and as you can see, we still had some tear out, but it didn't tear out as bad and it held on. And here's the finished part minus the threads, and I'll probably make some type of collet adapter to grab it right here and do the threading to mount in there. I'll 3D print something or cut a metal one. That's the perks of having machines like this that will allow you to actually make the parts to make holders for stuff like this. But all in all, we have a missile tip, a bullet tip, you know, a turned piece with a snout, chamfers. So, and this was done out of wood. You know, understand a lot of this stuff is going to be better in metal. You have a lot more structural integrity, you don't have grain issues, and on top of that, I'm using a carbide insert tool, when wood you really should be using high-speed steel. You know, so all in all, a couple modifications. I just changed things just like I showed you in GRBLGru. And we got a nice surface finish on it, you know. So all in all, for a wood piece, I say we did pretty good. Now I think it's time to go ahead and do some metal.